All right. Hope you guys are doing okay. Just me checking in with you guys. Working on a few things with our antiderivatives. And yes, antiderivatives are the same thing as integrating. You know me in English, like integrating would be your verb, right? That's what you're doing. And then your antiderivative would be more of your noun, because that's more what you get in the end. That's, coming from the non-English buff that I am. But just trying to sort of get that down pat and then looking at some other examples. Okay. The first one we're going to look at, and again, these are also on the notes for today. It has notes and it has homework. These are my note problems. It gives me a whole bunch of ones that I need to simplify before I go and try and find the antiderivative. If you see something like, oh, I have something raised to a power and I can actually go and do that, you should. Okay, that's going to make these easier. We shouldn't have to do any kind of chain rule right now or any of that kind of stuff. So if you're like, I could do the chain rule, we're not there yet. So don't worry about that. So if I had this, okay, that would say, well, if I use my rule of take my number to the power, that's going to give me the 9, and then I multiply those exponents, that gives me x squared. So I'm really looking at trying to find the antiderivative, okay, or I'm trying to integrate, trying to use those different terminologies there, this term. And again, I'm going to move the 1/9 out in front because that's one of my properties and just rewrite that. That's x to the negative second. So then if I go and use my rule that says add 1, so now I'm looking at 1/9. And then if I add 1, that's going to make that x to the negative first. And then I multiply by the reciprocal there. That's going to say, well, I'm multiplying by -1. So if I simplify, I get negative 1/9 x to the negative first, which means the x goes in the bottom. And then I need my plus c. So that would be my original function, or that is my antiderivative. If I had 2 over 5x squared to the third power, again, I'm going to go and use that rule. So 5 to the third gives me 125, and multiply as exponents, that's going to give me x to the sixth. So again, brings back those rules for algebra. So from there, I'm going to bring my 2 out in front, also the 125, so I'm going to put that out in front. And I got x to the 6 in the bottom, which means I really have x to the negative 6. So when I go and find my antiderivative, that's my end of my rewriting or my simplifying. I'm going to go and still have that 2 over 125 times, if I add 1, that's going to make that x to the negative fifth, and then multiply by that reciprocal. So if I go and multiply, I'm going to get -2 on top. I'm going to get 625 in the bottom. And that x to the fifth is also going to go to the bottom because it is a negative exponent. And then because that is my original function, I have my plus c, which stands for I have some type of value there, some kind of constant. If I go and look at the next one, so I got x and then the square root of x. Well, that's going to be x times x to the 1/2. Again, when I multiply, I add those exponents. Well, 1 plus 1/2 is 3/2, which is why I went and wrote that there. So if I go and add 1, that's going to make the x to the 5/2. So now I have x to the 5/2. I multiply by the reciprocal, and then I have the plus c. Nothing else to do there. Done. If I look to the next one, I got x to the 4th times x to the, that's really 2/3, which tells me I need to go and make those have the same basis. So that'd become 12 over 3 plus 2/3, which makes that x to the 4/3. Then from there, I'm going to go and add 1. Well, adding 1 is like adding 3 up top. So x to the 17 over 3, multiplied by that reciprocal, and then plus c. Because there's nothing else there. There's not like 2 or anything. I just get whatever that reciprocal is. Then we get into, again, some more algebra concepts of just make sure I know how to distribute. X times x is x squared. Negative 3x plus 2x is negative x, and then minus 6. And then each of those terms, I'm going to go and find the antiderivative for. I'm going to add 1 and divide by 3. If I add 1 there, 1 plus 1 makes that 2. So I'm going to have minus x squared. Reciprocal of 2 would be 1/2. So minus x squared over 2. And then minus 6, that just says add that variable of x to it, and then plus c. And that is my antiderivative. If I had 2x minus 1 squared, that's going to tell me really have this. So it's going to get me to 4x squared minus 4x plus 1 dx. And again, I'm going to add 1 to each of those. So I already have a 4 times x to the third multiplied by that reciprocal of 1/3. So it just really makes that 4 over 3 times x to the 1/3, or x to the third. Then if I go and add 1 there, that's going to say, well, now I have 4 times x squared divided by 2. And then plus 1, that's just going to say plus x plus c. And the only thing that I would do there is not leave that as two fractions. I call that 4/3 x. The 2's cancel out, so 2x squared plus x plus 4. And then that's what I have there. If I had this cubed function, I'd find out what x plus 3 squared is first. Gets me there, multiply again. Now I'm looking at x to the third plus 9x squared plus 27x plus 27. And again, just go and find each of those separately. So x to the fourth divided by 4 plus 9x squared. Whoops. Add 1 plus 9x to the third, divide by that, plus 27x squared, divide by 2, or multiply by 1/2, and then plus 27x plus c. The only term I can really simplify there is 9 over 3. I can go and call that 9 over 3 would make that 3x to the third. Done. If I got x to the fourth minus x squared over x, I have one big fraction. Go and make them two separate fractions. So I can go and call that x to the fourth over x minus x to the second over x. That gets me to x to the third minus x. And then again, just like those problems up there, I'm going to go and add 1 and divide by that number or multiply by the reciprocal. It's the same thing. Minus x squared, divide by 2 or multiply by 1/2. It still gets me in the same place. And then plus c. And that's what I get there. Same thing. I can go and break this apart into two different fractions. And if I go and simplify, I wind up with this. Well, if I add 1, 1 plus 1 makes that x squared, multiply by 1/2, gets me x squared over 2. If I go and have negative 3 times x to the negative second, and I go and divide by negative 2, that's going to get me to where I need, which is going to say, oh, that's really plus 3/2. There's a negative over a negative. It's going to make that into a positive. And the other thing that's going to happen is that my x squared is no longer going to be negative. I'm going to move it to the bottom. So I should have x squared over 2 plus 3 over 2x squared and then plus c. And then the last one, even if I had a radical in the bottom, that's just the same thing as x to the 1/2. So again, I can go and rewrite it. X squared over x to the 1/2 minus 1 over x squared. And again, when I divide, I subtract exponents. So 2 minus 1/2 is 3/2. Nothing to simplify there, but that needs to be in the top. And again, in order to go and integrate, I'm going to go and add 1. Well, that's going to make that x to the 5/2 multiplied by my reciprocal, so 2/5. And then if I add 1 to my 1/2, I'm going to have x to the 1/2. And if I multiply by the reciprocal of 2, and don't forget there's a negative there, so it's going to be minus 2, and then plus c. And I can always go back and check these. If I go and take that derivative now, so if I went and took that derivative, I would multiply that out in front. They give me x to the 3/2, which is what I have here. And if I multiply there, it's going to be minus x to the negative 1/2, which is exactly what that is. So that gets me to what I need. Again, hopefully that just goes and looks at, I still am integrating or I am finding the antiderivative. Again, those can be used interchangeably. These are called also indefinites because there's not a start and a stop place. These are called indefinite integrals. Next week, we will go and look at doing some more work with finding antiderivatives. But this is just a start on one big basic rule that goes and tells me that if I have one term, or if I have a polynomial, or even if I have a rational function, I can actually go split it apart. And I can go and say, well, if I have x to the n power, then if I want to find my original, I'm going to add 1 to my exponents and then divide by what I have there. Okay, and then always go and add on plus c. If there's multiple terms like that, I just do it many, many times. But that is my one big rule, is if I go and I have the derivative, okay, or if I have a function and I want to integrate, I'm going to go and add 1 to the power, and I'm going to divide by whatever that power is. Okay, if it's that new power becomes a 3, I just divide by 3. If that new power is 2/3, make sure that I go and think about, I'm really multiplying by the reciprocal. That makes that a little bit easier to go and do. Also, if you gave me this answer, or if someone else gave me this answer, those are the same. I will take those either way. If someone gives me this answer, or someone else gives me that answer, again, I'll take either of those. I would probably leave it like that, okay? If someone gives me this answer or someone gives me this answer, I will only take this as my final answer, okay? Here, it's good. I'll use either of those, but here in your final answer, I should not have any negative exponents. So make sure that you go and rewrite those. Those are my big ideas. If you have any more questions, make sure to drop me a comment, and have a great rest of your day, night, whatever time you're watching this video. Hope you're doing well. Miss you guys.